So the next topic that we're going to take a look at is finding intercepts of a nonlinear function given its graph. And so to go through and find the intercepts, we're going to do it the same way that we did earlier with the linear functions. We're just applying it now to functions that are not necessarily linear. Okay, they are not a straight line. And so remember, all of your x-intercepts, okay, remember, are simply just the points where the graph crosses the x-axis. And remember, as far as an ordered pair is concerned, that every x-intercept is of the form some number, comma, 0. Okay, so that's how you're going to set up your x-intercept when you express it as an ordered pair. That y-coordinate, remember, is 0. While for the y-intercept, remember, that's simply the point where the graph crosses the y-axis. And again, as an ordered pair, that is going to be of the form then 0, comma, some number. So in this scenario, for the y-intercept, remember that the x-coordinate is always 0. Okay, that's where we're crossing that y-axis. Okay, so with that in mind, let's take a look at the following examples here. Let's identify then our x and our y-intercepts, if they exist, and express them accordingly as an ordered pair. So as you take a look at this first example here, remember, of course, your x-axis, your horizontal axis, the y-axis is your vertical axis. And of course, for the x-intercept, just simply looking for where the graph crosses that x-axis. And notice here that it is crossing at two distinct locations. Notice at -1 and also at -3. Okay, so those are our two x-intercepts in this case. And so we can express those as ordered pairs then accordingly. Okay, and so from here, then my x-intercepts are just going to be the ordered pairs, -3, comma, 0, and then also at -1, comma, 0. Okay, so those are x-intercepts. And then in a similar way, we can go through and find then our y-intercept, just finding where does your graph cross the y-axis. And notice that that is occurring at this location here. Again, notice at 3. Okay, so we're crossing the y-axis at 3. And so I'll express then our y-intercept appropriately as the ordered pair, then 0, comma, 3. Okay, so our x-intercepts and our y-intercepts. And so from here, then we can go through and do a similar thing with the other examples. Notice that in the first example, clearly a non-linear function, definitely not a straight line. While in the next example here, notice this is a straight line. So we'll go through and find the intercepts, okay, for this particular function. And notice that we're crossing the x-axis at 1. And so we'll express the x-intercept accordingly as the point 1, 0. While the y-intercept, notice we're crossing the y-axis at -1. So we'll express the y-intercept then as the point 0, comma, -1. Okay, so the x and the y-intercepts for example 2. And now let's do that for example 3 as well. So notice in this case, here's our curve. And notice that we are crossing the x-axis at one location. Notice this is going to be at 3. So the x-intercept would be the point 3, comma, 0. But notice the y-intercept. Okay, the y-axis obviously is here, and notice that the curve does not cross the y-axis. So in this scenario, there is no y-intercept. Okay, so this particular function has no y-intercept, and I'll indicate that by simply expressing none. Okay, so at no point are we crossing the y-axis. And one last time, example 4 here, taking a look at this one, x-intercepts. Notice that we're crossing the x-axis at two distinct locations. Okay, notice this time at -1 and also at -3. So I'll go on and express that. And so our x-intercepts, once again, would be at -3, comma, 0, and also at -1, comma, 0. And we have, notice, a y-intercept crossing the y-axis at 1. Okay, and so then our y-intercept would be the point 0, comma 1. Okay, so again, just identifying the x and the y-intercepts given the graph of the function. X-intercepts just where the graph crosses the x-axis, y-intercepts where the graph crosses the y-axis.